so this one is basically iterating, and then you can check like, okay, like you can check contains, or you can check not equal to value start with, like you want to find the countries are starting with the I letter. So anything you have possibility for the string, right? So this is a string, right? The first key you look at, this is a string and value. Suppose you want to do some condition on the value. So x of 1 you can do. Suppose you say, I want to find the count which is coming, suppose 10,000. So how many are the 10,000? These are the 10,000 count, only except this one, right? So this is also one way to remove this blank one, right? The two ways are there. One way is like using the key you can filter out, or using the value you can filter out, right? But value is not 100% sure, right? What will be the value, right? Okay. But key you can say, okay, wherever the key is empty, filter out, right? Okay, because value we cannot predict, right? Because value may be the sometimes more than 10,000, but it's empty, right? So in that case, based on the value, it will not filter out. So better to do with the key, right? Because this key is no sense, right? Because this is not a country, this is a blank value, right? So this kind of values we don't need our output, right? Okay, so whatever you know, right, integer functions, whatever you can do, you can apply here in the right side. After colon, you can apply the integer operations, right? Whatever you can do, greater, less, min, max, whatever. And if it is a key, the string type, you can apply on the string type of operations. Okay. Okay. So this is the basic fundamentals one, RDDs, and some more examples you guys should try. Okay. The RDs and data frame, as much as practice you do, you will find more hands-on, more experience of working, because there are many more examples are there. Okay, so practice is important, like how you understand the flow, right? How, if you are reading the data, after reading the data, if it comes as a RDD or data frame, then how you can apply the transformation. Okay, so you need to understand the transformations of the RDDs and transformation of the data frame. Okay, so if we are talking about the RDDs transformations, so RDDs also have the same transformations like group by, all those transformations are there. Okay, so if we see like how to add a new column, so everybody knows, right? If I want to add a new column, so generally we use in the data frame add a new column, not in RDD. So data frame dot with column, we can add a new column. Suppose I want to make a total salaries with bonus, right? So I have a one bonus column, and like I want to calculate the total salary. So I can, or grade, right? I want to check my salary, and based on the salary, I want to give the grade. Okay. So if I say df dot with column, I add a new column, grade, and I say when df dot salary column is less than 4,000, I will give the this new grade value will be A. If when condition, this is second when condition, if the values is greater than 4,000 but less than 5,000 equal to, then grade B, otherwise C. So this will handle all values less than 4,000, less than equal to, greater than equal to 4,000, less than 5,000, and more than the 5,000. Okay, so you can provide the grade C. So you will see when the grade column will be created, that grade column will have A, B, C grade. Okay. So this is like a new column you can create based on the existing column condition. Okay. So on the existing column condition, sometimes this kind of report card, right? Like students marks report card. We want to create a grade column, right? So we are getting the students marks, but we have to provide a grade. So this is the way we can do it. So here is a when condition is there. So when condition is checking the value in each and individual row, right? Whether the value of the salary is what the salary. Okay. Select is just whatever column you want to select, you can select it. Okay. Suppose I have a 20 columns are there, but I want only one column or two column or three column, only those specific column you can select. Okay. So in that case, you can do the select of a specific column. Suppose you want to create a one extra column in the select without using with column, you can do this way. So one way is like you can do the with column, but based on the existing column condition, you are creating a values. But here is bonus is common to all the people. That this bonus is zero point 0.3, right? 0.3 bonus I'm giving to all. So it means this lit we are using. What is this lit? Lit is a constant value you want to give to entire column. Okay. And you want to give as a bonus. Okay. Suppose you say another column you are creating bonus amount. So bonus amount is a 0.3% of 0.3 of your salary. So you are doing multiply of the salary, okay, and then you are creating a bonus amount, okay. And you can add a new column like a current date. So current date is a function. So these all functions, whatever functions you look at here in the functions are there, right? Import functions. So you have to, where is the import functions? Yeah, here. Actually, I'm not. So this is the pyspark SQL functions, and functions import current date. If you want to, if you want to import any other thing, if you want to import any other thing, you can import it here. Okay. So you can import it, any other thing, you can import it here. So, so when I say I have concatenation, so concatenation generally we do, right? Like first name, last name, middle name, right? So I want to do concatenation, first name, comma, last name. So first I'm doing comma in the double quote comma, again first name and last name. So it will do concatenation of uh, comma, first name, last name. You can do the concatenation. Okay, let's see. I will run this. So first you have a small data set. Okay, like you have a data set like first name, last name, gender, and salary. Okay. So like this, you have columns. You created a column. So you have a data, you have a column, and then you created a data frame. So data frame is a combination of data and schema. Okay. So schema is nothing but here the columns. Okay. So you are specifying named column. You are specifying the named column of your data, right? The first column is a first name column. Second column is the last name, then gender, and then salary. And you are mapping your data with the schema, that is columns, and then getting a data frame. Okay. Once you get the data frame, the first thing I'm going to do here, what is this salary one? This df. So what df dot columns will do? The key, df dot column will be taking all the column list. Okay. So df dot columns, it will be checking if the salary one not in df. So this is not there, right? Okay. If I say salary is, if I do this, what will happen? If I do this, what will happen? Or what this line is doing? Can anyone tell? Df dot columns, what is doing? What will be the value of this one? Df dot columns.
It will print all the columns like first name, salary,
Yeah,
grade.
yeah. It is not printing here. It is taking as a
Yeah,
list,
it
right?
is.
Because it
Yeah.
is a list, right? Df dot columns is whatever columns is a list, right? So it is taking this list here. Df dot columns is a, so either I can do df dot columns, or I can directly write this columns also, because column is nothing but same list of columns, right? Your columns, correct? So sometimes if I don't know how many columns are there in my data frame, so the easy way is df dot columns will give you the all columns of your data frame, right? Okay. So dynamically you want to detect your column, right? Whether this column is there or not. So sometimes I want to check whether the column exists or not exists. So I can check membership operator. In Python, not in or in operator is there. This clause, not in or in. So I can see, and then I can do some operation. I can do some data frame operations I can do. Okay. So here simply I'm checking if the salary not in. to do this print statement. So something I want to check my list of columns. So I'm writing a if condition. Okay, so this is nothing. So with column is adding a new column. Okay. If you want to directly give assign a constant value, use let. Okay. It is also in the functions. Okay. If you want to assign some calculation, so any particular existing column multiply, you can do that the value. Okay. So you will get that value. So you will see here, this is all changes, right? You can get it. So starting from the very first one, and this is A is printing, okay? And after that, when you are doing this salary and bonus percentage. So bonus percentage is the lit hard-coded value that is coming. Again, bonus amount. Bonus amount is a 0.3% of your salary. So that you are getting here in the this next one, bonus amount. And the next one is the name. If you see concatenation, sometimes I have to concatenation of the columns, right? So I want my comma. So what I'm going to do, I'm creating a one column name column with column, and I'm concatenating the first name and last name. Okay. So first name, last name, I'm doing concatenation. And here is the only current date I'm getting. So current date I'm getting. Okay. So today is the 30th date. So only current date. Current timestamp is also a function. Suppose you want to get, I think current timestamp or current. Actually, I have to import. The current timestamp is there. As I remember, current timestamp. So I'm going to use here. Okay. So if you want to use the current timestamp, so you will get the timestamp. Okay. And grade one, you remember, right? Grade one is it's a when condition, right? So based on the salary, I'm getting the grade. So 4100 and 6200. So less than 4000, I'm giving A grade, right? That is correct. 4100 is a B grade that is lying inside this. And the other one is C grade. Okay. And here is a, I'm just doing first name, salary, and third column, I'm creating a bonus. So that is your constant value. Okay. So third column is the bonus, and the bonus amount. So bonus amount again, this one, and today date is this, right? Okay. So this is the data frame operations. These are the all data frame. Suppose same thing I want to write in the SQL. So I can do the spark.sql queries. So in the spark.sql query, so first I need to create a temporary table. So what is this temporary table name is PER. Okay. So whatever table name you give, alias name you give, same you will use here. Okay. Now same queries I can write in the SQL. How I can write in the SQL? Select first name, salary, and 0.3 as bonus. So same thing I'm writing here. Salary multiply 0.3 as bonus amount from the table name. So when I'm writing this SQLs, so I will be getting a result of the SQL. How to write a when condition in the SQL? So we have to use case and when. Okay, you know, right, in the database SQL queries, you write case conditions. So case salary, when salary is less than A, else B. Okay. If I want to put one more condition, so I will write another case when condition. So I can write multiple case when condition, and finally we can write else. Okay. So we can else, and then we can write it. So this way we can do. So this is the SQLs. These are the SQLs, right? So we can write SQL. Okay. Now next we go to aggregate functions. Okay. So aggregate functions are like aggregate functions are average, sum, min, max, medium, right? This kind of aggregate functions we can use in our data frame. Okay. So if I want to find the first salary, last salary, max, Okay, this is, I don't know, purpose. Mean salary, mean, and these are the variation types are there. These are the variance and mean, mode, median, right? Okay, statics related. Okay, so some of the things are related to statics. Okay, so statics related things are there. So if I have a data, and this data is name column, department column, and salary column. So three columns are there, and here I want to find the distinct, right? So I'm calling here. Okay, this is a API function. So this is a API function. Okay, I was thinking this function I created, but this is a API function. Okay, and the average salary, and then I have to do collect. Okay, so when I'm getting this data, I will be getting a data as a data frame. Okay, because I'm doing select. So after the select, you will get a result as a data frame. Then you have to collect a specific one value. So you have to do 0, 0 index. You have to define. Okay. And if you want to get a collect list of salary, like you want entire column salaries you want, so there is the collect list is there. So in the select, you do collect list and give the column name. So you will get entire column as a list. Set, set will be giving you the unique values. So when you give the collect set, it will be giving you the unique values. It will be giving unique values to you. Okay. So collect set means unique values you will get. Suppose you want to print all the salaries of your column. Okay. Like you want to take it, even though these are the duplicate. So you can use collect list. Okay. If you want unique salaries in your column, salary column, you can use collect set. Okay. And if you want to print a schema, so this is schema is coming. So whenever you are creating a data frame, so it will be showing the column name, okay, and data type, column name and data type. Okay, so that is the schema. Okay, so schema is nothing but your column name and data type. After that, I'm printing the data, df.show. Okay, after that, I'm doing a distinct. So I'm finding the distinct count. How many salaries are distinct? Can you check here how many distinct salaries are there? So one is a 3000 is a distinct, 4600 distinct, 4100 distinct. This is repeated. 3300 distinct, 3900 distinct, 3000 is repeated, 2000. So total how many are there? 6. So 6 out of this. Are these the 6 or not? 2, 3. This is repeated. 4, 5, and 3000 is repeated. 2000 is 6, and 41 is the repeated. The total 6 are the distinct. Average, the complete all salaries. Okay, so you will be divide the number of total salary it will do, and divide by the how many record? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 record, you will divide by 10, then you will get the 2400 is the average. Okay, I told about the list of salaries. All salaries are coming or not? Can you see here all the salaries? But it is coming in a single column, single uh, as a single value is coming. Okay, so don't understand this list is giving you the as a column. No, it is not giving an entire column. It is giving the entire column value as a single cell. Okay, so you are getting a list, a kind of list. So sometimes you want to find your all the salaries as a list, you will get the collect list. If you want to find the unique salaries in this one, same like 1, 2, 3, 4, 5, 6. So 6 salaries are the unique salaries. Okay. Count of distinct department salaries. Okay. What is this query? Count distinct. So I'm doing this one. So count distinct department and salary. So this combination I'm checking department and salary combination, the unique combination. Okay. So if I do So if I, instead of this, I just I select the column, okay, and then dot show. So department and salary combination, count distinct of. So count distinct, any number of columns you can give, 2 column, 3 column, it will find the uniqueness on the set of columns. So right now it is finding the uniqueness on the 2 columns. So total 8 record it found. Okay. So this combination of the department salary, if you give only department, so you will see the 1 column. Okay. So here, if we look at, is still processing. Okay. So if you see the sales, 3000 is a unique combination. Sales 4600, sales 4100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one is repeated? Is count distinct on the department salary. See, this is repeated. This is repeated. So it will not be considered, right? This is repeated. Okay. And finance 3000, finance 3300, finance 3900, marketing and sales 4100. So these two are repeated. One is this is repeated and one is this is repeated, right? So these two are repeated and these two are removed. So how many total count is coming? The distinct of the department salary 8. So this is a direct function is there. So this is a direct function which is finding the count distinct function. So count distinct you can give. So if you want to check count distinct on the department, okay, so you give only 1 column as a department and you want to find count distinct. Okay. You know, right? Like distinct and count we can use together, right? First I find the distinct value and then I can apply count over on that. Then I can find the count distinct. Okay. So count distinct is giving. So this collect of like this is a RDD, right? So because we know RDD is the row and column combinations, right? So we are telling about the first row, first column. Okay. So that we do the collect. Okay. So this is the RDD way we are doing. Okay. Otherwise we have the take function is there. Okay. Let me show you. Okay. So there is another way of take is there, or RDD way you want to do. So data frame dot collect, it will give you the RDD and then you say first row, first value, because only single value, single column, single row, single column, then you do the 0 of 0, right? Okay. So this is data frame. You are getting the as a RDD, you are getting the data. Or otherwise, if you want to take the value, you can take it by take function. Okay. So if I say dot, then we can print it, or it is not giving a data frame. Data frame 2 dot, let's see, data frame dot show collect take, we have to give the number, which record we want to take. if I show, we can do, and then sometimes you don't want to show a single value as a data frame, as a row column. You don't want to do. You want to use it, that value, as a single value. So in that case, we use this one. Suppose this one, and I'm converting it to str because it's a number. Then I'm converting into the str. See, single value is coming wherever this min max. So if you do the, but this value you don't want to show as a tabular representation. Okay. So in that case, if you want to use that value, you can use this collect. Okay. So collect where you can do. Okay. Wherever our one, which I printed distinct count of distinct count of. So after this, the value is coming 3, right? Distinct count, this one. Okay. After that, I printed this. So now it's printed df2. So this value is coming like this. This is the list is coming. Okay. Now when I do the take, okay. So it's a row of this one is coming. Further, so this is a row of count of distinct department equal to 3. So like this, we can fetch the value from this, and this is a count one. So either you can use the take, or otherwise you can use the collect, or you can use the show. So show will be giving you the single values, okay, just for the display purpose. But if you want to use it somewhere else as a single variable, okay, because you can't use it this value now, like anywhere. So you have to collect of 0 0, and then that value you can assign to some variable, okay, and then you can use it anywhere. But when it is showing means it is just for display purpose. You can't use it this value. You can't use it, right? Okay. So whenever you are getting the value here, you can say dot collect of 0, right? So this will be giving you the one single value, and that value you take it now in a some variable, right? You say this is the mean salary. So I say mean underscore salary. So now if you assign it to the some variable and remove this show. Okay. So now this value will be collected in your this variable, and now you can use it this variable anywhere else. Okay. So that is the purpose of to extract the value from your data frame. Okay. A single value. Okay. Is it clear? This one, this is the basically we use. Okay. So these are all aggregate functions. So you can see some of the salary, the sum function is there. Okay. So these are the aggregate functions. Okay. Okay. If you are working on the arrays, okay, string arrays. So like I have one column as an array column. So there is a scenario. I have a name column, language at a school, and current state. So this is the array column. And name is also comma separated in the double quote. If you see, name is comma separated. So three names are there: first name, last name, and middle name. And the languages are in a list as a square bracket list, and the current state is a single value. Okay, so when I'm just getting this data with the column, so my columns are this form. Now I want to separate it out my names, because this name is okay. We have comma separated, so there is a concat. Okay, if I have, I want to prepare for the first name, last name, middle name. So how can I do? So I have a column. Suppose I say full name column. This concat ws, I have to use it before. I have to use it before. Okay. So concat ws, and which column you want to concat. Okay. So either you should have the list values, because here is list values already there, but mine is not list value. I cannot pass like this column name here. Okay. Like I cannot say this column. Otherwise, I have to split it out. This is a string. This is a string. So first I need to do this particular column. I have to split. What is my column name? Name. So I have to split the name. Column. Oh, I have to use here the function name split. So unless I don't use the split, so then I cannot use. So I have the SQL function is a split. And I say here split column. Which column I want to split? Name column I want to split. Okay, df to df, df, my data frame is a df. So df name I want to split, and with what I want to split, with comma separated. So split taking a two parameter. One is taking a column or the value which you want to split, and the second thing, it takes the what So now you will get the, now I will get what? I will get the array. So if I want to just print it, what is coming in my split? So I will see. Okay. Here dot with column. This is ending. The indentation is a big problem, so you should always. So first I'm just doing the split. Okay. So it will convert this comma, comma, comma. It will convert into the three values in the, it will convert into the three values, right? So three values as an array. So it will come three values of the array. So I will see here. So name column I'm getting here. Added full name column. The full name column is where I added. This is the full name column. You see, it was comma separated values. Now it's a values is the not comma separated. Now the values are the array. Okay. So now I can apply the concat function, concat ws. So same thing like concat ws we use here for the array. So now this is also array. This is also array. Values are array. So if you want to do concatenation, so we can use the concat ws. So concat ws function. So we can give the values and we can give the whatever the values are there. So we can apply. So just whatever the values are coming in this array, right? So I'm just passing to here. Okay. So if you have direct array values, you can directly give your column name. You can directly give the column name. So all values will be concatenated by comma separated. Okay. If you don't have the values array, first you prepare the array values by using the split function in your data frame column and tell the delimited character you want to split. After that, you can do the concatenation of the value. Okay. So like again, you are creating a value as a string type. Okay. After converting. So where is the full name? So can you see the full name now coming is the as a string back again coming, right? Okay. So here, right? So you have converted array and array to again string. But I say like I don't want the middle name. Okay, here is the first name, last name, middle name, right? So I want the values which are like, okay, so here is three values. Here are the three values, but the last, so it is one value is empty. So how to identify? Generally, the last name, okay, I keep it this one empty. Uh, Now I say I want first name and last name I want. I don't want the middle name because middle name is empty. So when you are concatenating the values now, so you specify the after this you are getting the array. So array of what value you want. So array of this is you giving you the array. Okay. After that you do square bracket of 0, comma, you say square bracket of 1, 2, 0, 1, 2. So I want 0 value, I want 2 value, 0, 1, 2. I don't want all the values. Okay. So what it will do, it will remove this empty one. Okay. Otherwise, this one and this one is a no difference, right? So initially it was a string only, right? It is a string. So what we are doing, we are converting a string to array and again converting back to the string by removing this value. Okay. So this kind of transformations you may have to do. So sometimes you have some empty values are there in the comma delimited value and somebody is asking to you remove those empty values. Okay. But for that, we have to write some condition. Okay. We have to write the condition any of the index value is empty, don't do the concatenation. So we need to write a condition. Okay. But here we know middle name is empty. So that is the reason we are taking directly the hard coded index of 0 and index of 2. So I know that is the reason I can directly do. But suppose you want to write something code, you don't know which one is empty. You want to just take non-empty values. Okay. So you have to check each index value is non-empty that you do the concatenation. So you have to write this concat ws here. You have to write conditional logic. You have to write, right? So each individual array value, so you can check, right? Mm. Can you see now it's coming good? The full name, there is no empty value is there, right? So here is a middle name is empty. So that middle name empty, we have removed it. Okay. Okay. If values are the array type in the, see, it's same thing they are doing. Like whatever we did, they are split df dot name, comma separated and name is array. So same thing they are doing here. Okay. And this array, okay, so like you have current state and the previous state, the array values, and you want to give the state. So how it is coming? So if any, like you want to find the rows in the array values, Java is there. You want to find those rows only where the language is Java. If somebody is having the language Java only, I want only those rows. I don't want all the rows. If you see here in this data, only this row is having Java, this row is having the Java. In this row, there is no Java. So I want my output, these two rows. How to do this? So there is an array contains is there. If you check array contains, if you check array contains and check which value you want to check. So suppose you are checking Java. So what will be the result of this one? It will be returning true or false. Okay. So wherever the Java is there, it will be giving a true. If it is not there, that row will be false. So I have done the filter by using array contains true. So array contains true means only two rows having Java. So last two, this two rows Java is coming, right? So if you want to filter out, because you cannot directly match the values because it's array values. You cannot say like this particular value is only one single value. It's a list of values. Okay. So we have to use array contains. Okay. And if you have like array values you want to show, like you have a current state and previous state. So two columns I have. If I see in my data, yeah. So two columns are there. So if I see in my original data frame, So two columns are there. You want to combine these two columns and say, I want to show as an array. Okay. So I want to show the collection of the values of the two columns. How can you make it as an array if the columns are two? So here is a simple thing they are doing. Just make it array as a function. Array is a function and pass both the columns. If you have more than two columns, comma separated, you can give the more than two columns. So it is like a joining of the column. It is joining of the column row by row. So if you want to join the column row by row, then you can use array and you can make it a single column and give the name to the single column as a state. Like this guy has current state, previous state. I want to all combine and make it one single column state, right? Okay. So sometimes the transformations are like that. You have some existing data and sometimes you are getting a new data, some new column, and somebody is asking to you merge these existing data column and new column data, both are the same type, just merge it and keep it one single column. So this is a scenario where I want to see like how many states. I'm not doing matter of this, which is a current, which is a previous. So if I say I want to know the this particular person, how many states he lived, no matter what is the current, what is the previous. So I don't need these two columns. Okay. So sometimes you are getting two columns and you have to merge and create a one single column. You can do like this. Okay. If you want to split it, so you can split it by comma separated, and then you can create an array. So string to array you can create, array to string you can create, or you can create an array of two column, two string columns. You can create a one single column as a array. Okay. And one more thing is in the column, in the array column, you want to check some particular value that you can find it. Okay. By using array contents. So did you understand this one? And this is an explode function. So this explode function is basically array values. It is making a single row. If you see how many times Java, Scala, C++ is there with this guy. So how many times it's coming? 3 times is coming. And Spark, Java, C++, this guy, how many times is coming? 3 times is coming, right? And the C#, VV, this, how many times is there? 2 times. So how many rows are created? 2 rows are created. So this is this is the explode. So explode is a function which is converting your array values into the individual row. Okay. So you remember, right, in the hive explode function is there, the same explode function here, which is making your array values to the explode, okay, into multiple rows. Is it clear, this one, everyone? These are very important, like arrays related transformations, okay, right? Whenever you need to do the transformation, so you need to understand how to explode, how to split, how to concat, how to check arrays, and how to convert into array, how to split. Okay, so all these. So there the two things are there, map to column and column to map. Suppose you have a map values and you want to convert into the different columns. And there is another scenario, you have list of columns and you want to convert to the map. Map, you know, key value pair, right? You know, key value pair is a map. Okay. Just see the scenario here. You have a data, you have a like a first name is there, and this is the key value pair set is there. Like here is a black, I is a brown, here is a brown, I is a none. There is no value is specified. So this is a key value pair matching is there, right? Can you see this is a key value pair dictionary? So in the this dictionary data is there, right? In the list. This is a list, and list is having the tuple. This is a tuple because this round bracketed tuple, and the round bracket tuple is the dictionary. So you can say it's a collection of dictionary inside the tuple inside the list, right? So list is this list is of tuple of dictionaries, dictionaries and single value. Okay, so two items are there in the tuple. One is a single value, one is a dictionary item, is the items of the tuple. Okay, and here you are giving a schema column. So first of all, you decide your data is a two column. In the tuple, you check how many comma separated value. Is this comma is there, right? So this comma means this is a first column and this is a second column. So one column is a name, this is straightforward. But the second column is a properties column and it's a dictionary type column, right? So when you will show here df.show, so as it is value come in the column because whatever value is there as a dictionary, it will come as it is. Okay. It will come as it is in your column properties. Okay. Now I have to do some transformation on this properties column. Name column is a very straightforward. You can do any string manipulation. You can do like you want to check name or you want to check any string contains start with anything. You can do the first column, but the second column is not a straightforward column. It is a dictionary type column, list column having a dictionary items. If you see the schema, first you check the schema. So this properties is saying the map type. Definitely it's a map type only. And map type of key and value. Can you see as it is data is coming? So when the data is parsed, the data is parsed and it is coming as a key value. Okay. So key value data is coming. Now I want to make it this dictionary data as a separate column. So what is the if you see here, the file name is map to column. So you have a data in the map and you want to convert into the column. So how many column you want after this conversion? 3 column. Name will be as it is, and the one column will be the here, and the third column is the I. Okay. So how to make it separate, right? How to make it separate the columns, right? So after this print schema, so here I'm checking x dot name. What is lambda? Lambda for each of the column value it is taking, but this is in the data. So here I'm converting into the RDD. Okay, I'm not doing directly lambda on the data frame. So data frame dot RDD, I'm converting data frame to RDD dot map function I'm applying and saying each row, like I'm taking each name x. So x dot name, x dot property, x dot property. So I'm converting again back to the data frame. So I'm reading the data, I'm converting data frame to the RDD. Again RDD, I'm converting into the data. How I'm converting? First time making it a single value, right? I'm saying x dot property. Okay, x is my this one single row x, and x dot name, the first column value, x dot property, second column, and there is a dictionary. If I pass the key, I get the value. So what value I will get it for this guy James? Black. And eyes I will get brown. So I will get the values and I'm just converting to the 2DF. So this entire data frame will be converted RDD and it will run one by one for each row by row, because RDD goes row by row. Okay. So RDD goes row by row and then I converted to 2DF. And after that I got this. Okay. I got the data frame back. Okay. After this, suppose I'm saying now I want to add a with column. So this is another way. If you don't make it RDD, directly you say I have a DF and I want to add a new column here. Okay. So I add a column here and simply whatever your column name is there, df dot property is a column name and get item is the item. You can get the item of here and get item of I. So this is without using the RDD conversion. You can directly apply on the data frame. So this is much easier. Just use with column, you add a new column and then drop the properties, because this existing dictionary column I don't want. So I dropped it. Okay. So I created two new column by taking out the get item. Okay. And then I will be using. Okay. Another third different way, other way, because all these answers are same, all these are same. So another different way is like here, df dot properties. If you don't want to use the get item, so they have given directly, you can pass the dictionaries item, you can pass key, same thing like whatever you did here. Okay. Okay. So here also the same with column you can use. Okay. So these are the two ways of the data frame, either get item or properties of column name. Okay. So if you want to use the explode function, this is another one more way. Like that is the explode. Explode, you know, explode we can do array item or map items, like we can explode. So simply explode function you apply, and you are getting all the keys, all the distinct keys. So what are the keys are there? You are taking all the keys in the keys data frame. Okay. And keys data frame, this is a little complex. And keys data frame, you are making rdd dot map, and then you are getting its values. So this is the values key list. Okay. And this one you are again forming, right, your what you're doing, this column get item alias string of x and key list. So key list you are adding here, and I think key list you adding here, and lambda of x list of, so list, this is a list constructor, and this list constructor you are saying map of x column properties. So each value you are taking map function you are applying. Okay. So map function you are applying here on this key list. So first you prepare the key list. This is the purely Python approach, purely Python approach. Like if you do in the same thing in the Python, you will do this one. Okay. So here in the Python is like map function you are applying on the this particular lambda you are applying on the your list, this list. So each value of this list, it will take one by one in this map function and get the item and get the value. Okay. So you are creating a key columns, right? You are preparing the complete column, and then you are passing it to the data frame, and then you are getting. So this is the same thing is saying, this is the same thing with this approach. Okay. Okay. Another one is a column to map. Suppose you have a different column and you want to create a key value pair. So you have a ID, department, salary, location. So first you understand the scenario, what the scenario is here for the key value pair. I say I want to make it association of the two different values as a key value pair. So I say I want to create map function is there. You know, right? There is a list is there, right? And you can make it salary. Okay, lit of salary, salary comma salary, location comma location. Then I'm making it this key value pair type. Okay. So this key value pair type you are creating by using the create underscore map function. It is a part of the function. And you have given the name of this one is the properties map. So two separate column, like not two, salary and location, you are creating a map. Okay. So if you see here, I want to keep it other two column, salary and location column as a map column, and other two column I want to keep it as it is. Okay. So whatever my DF is there, I want to keep it my DF as it is and add a one column as a properties map. And I'm adding a create map function. I'm creating a function on my two column I want to create as a key value pair type. Okay. And then I'm dropping my the salary location column. because this salary and location column I created as a map. So we need a column name and the column value, right? Salary and salary value, location, location value. So like this, I want to create a key value here. Okay. So this is, both are clear. This is our like opposite to each other. Map to column and column to map. It is bi-directional conversion, right? So either you can do, if you have column, you can create a map, or you have a map, you can create a column. Okay, so you can do. Okay, let me show some joins. Okay, so joins you will get idea. Filter, all these are there. Group by query, join. So join, there are the different types of joins are there in the Spark. Okay, the inner join, left outer, right outer, full outer, and cross join is there, and left anti join and left semi join. Okay, total 7, 8 joins are there. Okay, so when we are doing the simple inner join, so we say like one common column is there in the department and like two tables. So here is a department, department ID and department name. And the employee table has employee ID, employee name, and date of joining. All these columns are there, and supervisor employee ID. The supervisor is like any, like -1 means this guy has no supervisor. Okay, so just the value is -1. -1 has no significance. So the one supervisor, the one employee ID has no supervisor, but the two has supervisor one, three has the supervisor one, four is having the supervisor two, five is having the supervisor two, and six is having the supervisor two. So one and two are the manager of other employees. Okay, so here year of join, okay, and department ID, employee department ID, and gender and salary. So this is my data set. So I read first these two data frame. The one data frame is the employee data frame, and second data frame I data. So this data frame you are preparing manually here, but you can read the same comma separated data from the CSV file. So you can use spark.read.csv and you can get the same data from the CSV file. So here for just practice purpose, we are preparing the data, but most of the times we are getting the data from the files. Okay. So once we are getting the data from the CSV file, then we create a data frame. So till here, it is just creating a data frame. So two data frames we created, employee DF and department DF. So two ways we can write a join. One is using the data frame API, and the second one is the SQL queries. If you see, this is a SQL queries. No, this one. This is a SQL query join. So same thing, whatever you can do with the data frame API, everything is possible by the SQL query. The SQL query is easy, right? We know just SQL and we write a SQL. But data frame API also easy, but just you know about the what type of join you are going to use. If you use double quote here, inner join, so it will apply the inner. If you do the outer, so it will be using the left outer. Outer means left outer. So outer is left and the left is left, left outer. Okay, actually outer is a full outer. So outer, full or full outer. Actually, these three are same. Left and left outer same, right and right outer same. Okay. So don't be confused. If you outer, full and full outer, all are the three same keyword and it will be giving same result. Left and left outer, it's a short form of the left outer is the left. So generally we write full, left or right. So full is means it's the full outer join. So full outer join means like it's a left or right, both side data, whether it's matching or non-matching. Left side is left side all data and right side matching, and non-matching on the right side will come null. In the right outer join is the right side all data and left side matching, and non-matching in the left will come null. Okay. Left semi is, suppose left is matching record in the right side, only that will come. So you can say exist operator. Exist means something is in the left is matching with the right. That is left semi. Left anti, something is present in the left, not present in the right. That is left anti. So just we try to find out the result. If I say first we start left anti, which IDs will come? Can you tell me? If it is a left anti join between the EMP department, which rows will come? Left anti. And left anti and left semi, only left side data will come. Right side data will not come at all. Okay. So tell me which rows will come in the left semi and which rows will come in the left anti. What I said, left semi and left anti. Left semi means something is present in both, okay, which is matching. And left anti means something is present in one which is not present in the second. That is left anti. For left anti, you tell me what will come. Left anti. Okay, compare it. 10 is there in this. 10 is there. 10 is there. This 10 is there. Yes, right? 10 is there. Correct? 10 is there. It will not come. 20 is there. Is there. It will not come. 30 is there. 30 is there. 30 is not there. Right? So which row? Okay. So 10 row is there. 20 row is there. These are matching rows. Right? 10, 20, 30. If you see 50 row, this row is here but not here. Correct? So this will be coming only in the left anti. Only one row will come in the left anti. And the left semi, what will come? Opposite of that. How many rows will come in the left anti? 10 will come, 20 row will come, and 40 will come. So 10, 20, and 40 will come. 30 is not there. Okay. So if I say in the left semi, these data will come. And left anti, what will come? This data will come. So can you see the left outer join is a combination of left semi and left anti, right? Because when I say left outer join, so left outer join, definitely all left side data will come, right? And right side matching data. So how many matching are there in the right side? 30 is not matching. Okay. So left side all data, but 50 doesn't have the right side data. So it will come null, right side. Okay. When you do right outer join, how many record will come? So 10 will be matching is there. So 2 record in the 3 record of the 10 will come. 20 is how many record? 20 is the 1 is there. And 30 is coming in the right side, but not a right left side. So here the right side part will be null for this 30. And 40 is matching is there. Okay. So only 2 columns and along with it, the left side one will be null valuable. Okay. In case of 30. Okay. Okay, let's see this, then it will be more clear. Inner join is basically simply the IDs are matching IDs, only matching IDs it will come, both sides. Okay, like 10 is matching, 20 is matching, and 40 is matching. Okay, 30 is not matching, so that will not come. And 50 is not matching, that will not come. Okay, only matching rows data will come. Okay, so one inner join, full outer join, both side all data will come, no matter is matching or not matching. So 10, 20, 30, 40, 50 all will come. Okay, let's start to match. This is our initial data frame. Okay, better to comment to. Okay, the first is this data frame and this data frame. Okay, let's come to the inner join. Inner join is checking the department ID equal the department PF department ID. How many department IDs are matching? So 10 is matching, 20 is matching, and 40 is matching. 10, 20, 40 is common. Can you see only 10, 20, 40 is coming? Rest of the other are not coming, right? Same department, because it's coming two times, because one department ID column is coming from the employee and one is coming from the this one. Okay. So 10, 20, 40 is coming. So that is coming. Second one join is the inner join. After that is the full outer join. So full outer join, I told no matter is left or right, all are coming. So 10 all are coming, 20 is coming, 20 is only one record, and 40 is a one record, and 50 is coming. So left side all data and right side all data, both side all are coming. Okay. So here 50 in the left side is there, it is coming. 40 is the left side is coming. 10, 20, this is the left side is coming. But the right side is 30 is there, but left side there is no data. This is the null. Null is coming in the left side, right? Because for this 30, there is no data in the left side. So all data of the left side null coming. And the second one is 50 is in left side, but no corresponding record in the right side. So that is reason null is coming. So if you see inner join, only 3 to 5 records are coming. And here is a 4 and 3, 7 are coming. So which one is coming extra? So like matching this 10, 310, 120, 140. So 50 and null, this one. So here is a 150 and here is a 130, which is non-matching from both sides. So this 30 is non-matching to the left side and this 50 is a non-matching to the right side. Okay. So this is the same thing will be in the, this is same like a full, right? Either you do full, outer, or these three are same. So these three are same. Now this is the, so this is my inner join. This is my full outer join. Okay. This is second full outer. This is the third full outer. Okay. So these three are the, all three are the full outer. Now next is the left and left outer. So now we come to this one. This is my left and left outer. So left and left outer both are having the same result. If you see these two are same, these two exactly same, right? And left side all data is coming 10, 10, 10, 20, 40, 50. And right side is, if it is matching, matching will come, non-matching, null will come. Okay. So same thing is the left and left outer. Left outer both are same. Okay. Now we come to the next two. This next two, okay, the next two, this one, this two. So these two are the right outer join. The right outer join is the right side all data. If I see the department, so right side is a department data, department ID, department name. So all department are coming 10, 20, 30, 40. And corresponding to the right side, the left side is all corresponding data is coming 10, 20, 30, 40. But 31 is not there in the left side, it is coming now. So that is the right outer join. Okay. Same thing is here also, because both are the right outer join. After this, the last two, this one, this is what? After left outer, right outer, and this is the left semi and left anti. Okay. So these two are the left semi, left anti. Can you say left semi what is coming? Matching is coming, right? So left side to right side matching is coming only from left table, not right side. Okay. Just right side data is just for matching purpose, not display purpose. Okay. So department ID and name is not coming here from the department one. Only left side data is coming, but all data of the left side, which is matching to the right. But 50 is not coming. Why 50 is not coming here? In the left semi? Left semi 50 is not coming because it's there in the left, but not there in the right. Okay. But when we do left anti means something is there in the left, not present, not present in the right. So only one is there, 50. So 50 department ID is present in the left, but not present in the right. So only one is coming. Okay. So this is all about this one. And now through the SQL query, so SQL query, they are doing this one. So SQL query, this is a self join. I want to find every employee's name whose supervisor employee name. Supervisor employee ID and supervisor employee name. So there are the two supervisor only. Employee ID 1 is a supervisor and employee ID 2 is a supervisor. Employee ID 2 is Rose and employee 1 supervisor name is Smith, right? So this is a self join. Like we can do the same table alias like we are doing the join. So here simply I'm doing a EMP is a 1 and EMP2 is the same employee data frame. So both data frame are the same and I'm checking here like supervisor employee ID is equal to the employee ID. So anyone who is a supervisor of employee, he is a himself is the employee. And what I want to get, I want to get the employee two. I'm saying this is a supervisor employee, supervisor employee ID and supervisor employee name. Okay. If I same thing, if I want to do with the self join SQL queries, how I can do? So I can write a spark.sql query. I can write spark.sql and I have a table. I have to create a table out of that. So like employee df, employee df dot create or replace 10 view. I will write a query, select. Okay, the two aliases I need from, I say employee, just I give simply EMP. Okay, so two aliases I'm creating, EMPE, okay, EMPM or EMPS. Okay, so employee on, I say E dot, so any employee ID, like I say, like I am doing the employee supervisor ID. So employee, what is the column name? Supervisor employee ID. E dot any employee supervisor ID, okay, equal to I say any supervisor employee ID. And I want to display here E dot employee ID. Generally, this type of query we write whenever we want to compare the salary of supervisor salary, the employee salary is greater than the supervisor salary. So E dot name, okay, and E dot supervisor employee ID. So this we will get it in the same table because all three are related. Employee ID, employee name and supervisor ID and employee supervisor name. So S dot S is the supervisor alias, right? So I have to do S dot name. So this I will get it. So I will do print statement so that I can see. If you want to do the inner join in the SQL queries, it is very, very simple. Where this one, whenever you want to do inner join or left outer, inner join. So you can do inner join keyword. You can use comma separated, okay, or you can say what type of join you are going to do. Okay. So here I'm using generally inner join, you can write comma separated, but if you are doing the outer join, left outer, right outer, so you can use the left outer keyword. So if you write it here, left outer keyword, okay, left outer, then it will do the left outer join. Okay. But self join is the inner join, but both the tables are same. That is the difference. So self join is a join which is in the same table alias, and then you are doing the join. Okay. So even I can write the inner join also, that is fine. Okay. So third last will be my this result. Okay, saying on the on clause. The syntax error is saying e and comma. Actually, whenever you are using something like this approach, okay, um, so always use the where clause. Okay, if you see the syntax here, whenever you are using comma separated table name, always use where. If you are using like two table, you are giving left inner or outer, whatever it, then you use on. So it is clearly saying here this on is not recognized. So on is the not recognized keyword for comma separated. If I use inner join here, then I can use the inner join. Okay, the same query, if I write it like this and I say here on, and I say here not comma, I say inner. I think inner also works. Okay, got the point, right? Okay. See here also the same thing. Like whenever you are using comma separated, I'm not using the on clause. I'm using where. But when I'm using a inner keyword or something, right? So then I have to tell on. Okay. Otherwise it will be a syntax error. So do practice on all this. I'm telling you, like they have given so many examples, left anti join, different examples. I think if you first initially do practice, so you will easily come to know how they are doing using a data frame API or SQL, right? And there is a windowing function also there, like dense rank. So you can search here, dense rank, Control Shift R. So Control Shift R you can do and search dense rank, right? Windowing function, how to use the windowing function. So you can search dense underscore rank. So this is the pyspark window function. So this particular examples, all window functions are covered. So you can do the complete window function practice like rank function, dense rank function, percent rank function, and there is a row number function, lead lag, right? So this is the window specification we have to create. So whenever we are using the window function, so we have to create a one window, and window is basically the partition by clause and order by clause. Okay. Generally, we do use of window function for rights if I want to find the third IS, second IS salary department wise. Okay. So salary is descending order. I can make it. Okay. I think I have to write a inner join completely. So second query got failed. If you see this query or this query, result is same or not? 1, 1, 2 times 1 and 3 times 2, and Smith 2 times and Rose is coming 3 times. So my this particular query is correct, and I think I have to write. So if you see error, just identify the error. What is the error here? See, here is it is expecting inner after join keyword, but what it is finding here? It is finding the EMP. So that's a wrong. Okay. So inner join will come completely here. Okay. If your syntax is not completely correct, so it will give you the syntax error. Okay. This is not logical error. So logical not error here, the logical output will come different. Suppose you want to use the left outer join, but you applied inner join. So your result will come based on the inner join. If you want to apply the full outer join, but you applied left outer, your result will come different. But your output will definitely come because there is no syntax error. Okay. Maybe your data is not coming, so it will come empty. But in case of join, definitely the data will come either matching data, non-matching data, so it will come. So depending on your join condition, whatever join you specify, based on your join, the data will come. Inner join, left outer, right outer, full outer, left anti, left semi. So you can use this word between the two tables. Like, okay. So same, whatever I tried here, all data frame API, same you can do here. Same joins you can do with the SQL. Okay. So self join, I told you, right? You can write in a SQL query or you can use the data frame API. Okay. So self join is nothing but your inner join only. Okay. But just you are telling the same table join you are doing. Okay. So how many output are coming in the self join now? Total 3, right? Okay. So this time there is no error. So these 3 are the self join. These 2 are the self join. These 2 which we have given same data, right? So either you use the inner join or you use comma separated and where clause. Okay. So just remember the syntax. You can do the self join. Okay. So try this and windowing function. See this one, like how to get the salaries, department salaries, and this one. So you have a list of salaries are there. You want to department wise salary. You want to find the third highest, second highest salary, or you want to get top 3 salaries. The top 3 salaries, we will be giving a condition less than equal to 3. So top 3 salaries will be there. Okay. If I want to say only third highest salary, so I will give the equal to condition. So when I'm giving a equal to condition means like if I'm say row equal 1, so it will be giving me the highest salary because it's the first row. If I say row equal 3, so third highest I will get. If I say second highest, so I will change to this row equal 2. If I change it to row less than equal to 1 or less than equal to 2, it will be giving you the top 2 salaries, top 3 salaries, right? Because your salaries are in the descending order, the top salaries will be coming from the top, right? So highest salaries will be coming on the top. So from the top, you are taking the highest salaries. If you say somebody is asking you, tell me the top 2 lowest salaries. So you have to make it ascending order. Right now, I'm going to do descending order. So I will get the salaries in the top 2 will be coming on the top. Lowest one will be bottom. Okay. So I need to change the order. So these are the top salaries are coming in the department. If I say the finance department, the sum of the salaries of the all finance department, this is the sum. Minimum salary in the finance department is 3,000. So 3,000 is a finance department minimum salary. If you see 3,000 is a minimum salary. Maximum salary in the finance department is a 3,900 that is coming, right? So department wise, you are getting average, sum, mean, and max. But this is coming like top highest salary. like third highest salary I want to get. So in that case, like min max will not be like you will not apply. You will be, or some you will not do. Average you will not do. So generally top highest one you will be doing, right? Like what is the minimum salary of the department wise? Okay, maximum salary. So second minimum, second maximum you can do if you want to do the second minimum, second maximum. So okay, I do this too. So what will be the change? Wherever the minimum is coming, this is coming the highest one. The second highest minimum and second highest maximum. Okay. So you will get it by row equal to. So second row will be your rank, right? Row number. So that will be giving you the each department. So if I say in the sales department, 4600, 4100, second maximum is what? So first we see the maximum. Maximum is a 46 and second maximum is a 41. 41 should be the second maximum. Okay. Second minimum. Second minimum is I say, right? So first I find the minimum and then I will see the second minimum. So that way I can check. This is the rank is given. If you see, there's 1, 2, 1, 2. So not this one. So we have okay. So sales department, the max is second. I given second. Okay, row 2. So sales is coming second max 46. Oh, I'm not doing descending order. Mm. Okay, so this order by clause I have to make it. Actually, highest one we don't need a order by, but if I want to do the second highest, so order by salary, sort by. I think in the salary column itself. This I'm not using a sort by. If I use the order by column, order by dot ASC function, which column you want to apply. So ascending and descending is the DSC. So DSC or yes, DESC after column. uh, so using the rank or dance rank function, you make it suddenly always descending order, and take the second row number or rank or dance rank, we can take it. But if the salaries are like dance rank generally used when the repeated values are there. Okay, so in that case, dance rank will not be skipped. Okay, but rank is skipped. Okay, so remember always, so dance rank will be not skipped, but rank is skipped. Okay, if the same value comes twice. Minimum is 3,000, second minimum. So if I see one department, we take it. Okay, sales, we take it. So sales is see this dance rank one. So here the dance rank, this is coming all the dance rank. So if I say the sales is the 4600, 41 is the second rank, dance rank, and the third is the sales. So according to this one, this should be picked up, right? Because this is the second highest, okay? And here is the second highest is the in the finance one, 3300. Okay, this is the second highest. And here is the second highest is in the marketing, this is the second highest. So we have to pick up this salaries. So whatever your dance rank one, there you apply. Okay, this is the dance rank I'm doing. So here dance rank, and here where some name dance rank to. If you want to second lowest, so make it instead of ascending, make it descending, make it ascending, and then you take 2. So this value will remain 2. Only thing is you want descending or ascending. Based on that, you will get the lowest or highest. Always get the highest one. So make it descending and take second. Okay, so it will be coming from the top, the highest, second highest. If you want to get the second lowest, make it ascending and take it from the top. That will be okay. So we have to check the dance rank one. Okay, because dance rank one, we apply this condition. See, now dance rank, when I did 2, so all second highest is coming or not, that we have to check. Yeah. So 3300 is second highest of finance department, 3300. This 33 the second highest. The first highest is the highest is a 39, then 33, and then 3000. So that is correct. And if I see the second highest in the marketing, so marketing there are the two records. So second highest is 2000. If I want to see the sales department second highest, so second highest is what's in the sales, 4600, and 41 is the second highest. So 41 is coming, but 41 is a two record, so both are coming. Okay, because second rank is on the two, so all are coming. Okay. Okay, try these examples. Okay, so okay, I will share the recording there. Okay, thank you.